Exercise 7. Updating the Azure IoT Edge manifest to add modules and routes. The diagram that we see here depicts the module implementation as part of this lab. You can see that we start here with our first module, which is the simulated temperature sensor module. We used this during month 1 as well. So this is generating data configurable by default every 5 seconds up to 500 telemetry messages. The way that we've implemented this for this hands-on lab is we see that we next move to an Azure IoT Edge Azure Stream Analytics module. So the Stream Analytics job that we just finished creating and publishing, the ASA average temperature job, receives data from the module. So last month we had data go from the module directly to the cloud to Azure IoT Hub. This time we're doing two things. After processing the data through the Stream Analytics job at the edge, we have one route defined that says where the average temperature greater than 21, send it to Azure IoT Hub. And then we also have another route defined that sends that to a custom C# IoT Edge module, which can be found in the Git repository. So you'll see average temp persistence module. This is the implementation shown on the diagram. You won't need the source files. A container has been published for this hands-on lab that will be pulled and used. The average temperature persistence module receives the data from an IoT Edge route, takes that data, and then inserts it into an Azure SQL Edge database. So this again is another Azure IoT Edge module, Azure SQL Edge. We have an average temperature database with an average temperature table. There's just 2 fields as we saw last month. When the event occurred, which is called window end from the Stream Analytics job, and then we have average temperature. And you'll see 2 things. We then also see Grafana here. Grafana, as we briefly looked at in our presentation material, is an open source tool for visualization. So Grafana is pulling the information from the SQL database so we can render graphs and such. So we'll get a chance to look at that as well. The last piece is the Azure IoT Edge module that's called cronexec. This is also a custom module, is just a custom Docker container that has a configured cron job that runs once a minute, connects to this Azure SQL database, and ensures that the database has been created and that the table has been created. So a quick review of all the modules here, along with the file locations that I mentioned before. You can find those here in the lab materials as well. Some alternatives for what could have been implemented here is it would have been possible to implement an Azure function running Azure IoT Edge module in place of that custom module. Really no reason for one versus the other. Having a custom application could be beneficial for lab students as well. Next is using Azure SQL Edge data streaming. So there is a feature linked here where you can consume messages from IoT Edge Hub and then directly insert those messages to a database. That's an alternative route that we could have taken for this lab as well. Again, no specific reason. This collection of resource links really covers everything in this section, since we're getting into more of the details and a bit more complexity here. If you're interested in more reading, follow these links. So What we'll do first is open up the Edge manifest modules JSON file. So again, in our hands-on lab directory, month 2, day 1, HOL files, we have a file Edge manifest modules JSON. So we can see it here. And there's a couple things to note here. You can see how modules are defined in the file. You see modules underneath Edge Agent. Edge Agent is responsible for instantiation and health of the Edge modules. So you can see here's our ASA average temperature module. We have our, and this is our stream analytics on the Edge. We have our average temperature persistence module. You can see here that this is referencing a container registry, an Azure container registry. You can see the repository for the container and the tag that's being pulled. Same thing for cronexec. And then if you look, we also have simulated temperature sensor, which we also used last month. So this is coming from Microsoft's public container registry. We have Azure SQL Edge. And the one thing to note that's different about Azure SQL Edge is the create options that are provided. So when you're working with Docker containers and you're doing things like binds and volume mounts and port bindings, you use the create options to pass those parameters along. So when we expose SQL, you can see here that there's a port mapping for the SQL port 1433 on the host and on the container. You can see how these two match. You can also pass environment variables. So one of the requirements for the SQL Edge container is that you do accept the EULA. If you don't set this environment variable, the container will fail to start. You can see that some other parameters are set, such as the password. You can see all of this is within the env tag or the environment section. And then our last container that we have here is the Grafana average temp container. And this is the one that is going to be pre-configured to know how to connect to SQL Server to retrieve our data. And it's also pre-configured for a dashboard. So when we log in, we'll actually have a visualization without pre-configuration. So all of those customizations for Grafana were done through a custom Docker container, which you can also look at the source files at a later point if you like. Then the last thing here is that we're exposing port 3000 from the container to the host, and we do this so we can expose the web server, which is running on port 3000 in the container, to the host operating system. So we'll have the capability to connect to it. If we look back at the lab materials, we also have an example of the routes. So right here before section 7.4, you'll see the routes that are used as part of this implementation, where we're taking from an endpoint and we're sending to an endpoint. So as we saw depicted in the diagram, these are the routes that are configured. Section 7.4, creating an IoT Edge deployment using the CLI. So we'll need to collect a few bits of information before we're ready to run the command. So let's run step 1, copy to your clipboard the command AZ IoT hub list. We'll run that command, then we'll copy the name that's produced. We'll go ahead and put that on our clipboard, so we have that for later. Then we need to go to our Edge manifest modules JSON file. We need to replace the SaaS URL, the subscription, and the hub name in the command below. So let's go back to our modules file. Let's find our SaaS URL. Come back to our file. And we'll replace the SaaS URL, including the squiggly brackets, the curly braces, very important. We'll come back, we'll find our subscription ID. We'll replace it as well. And then we'll save the file with Control S or File Save. Next, we'll go back to the lab instructions. And from our lab instructions, we will copy this command. So we'll copy to clipboard, come back to our scratch pad, and you'll see here that we do have hub name that needs to be replaced. So I'm going to take my hub name that I copied, and I'm going to replace squiggly brackets and hub name with that value. Reviewing the rest of the command, you can see that we are passing the Edge manifest modules file as content, and our target condition is dev. Our device we created earlier does have a tag of dev for environment, so this deployment will target it. So I'll copy all this back to my clipboard. We'll go ahead, head back to Visual Studio. We'll run the command. And we'll see that we've reported success. Section 7.5, reviewing the IoT Edge deployment in the Azure portal. So for this next step, we'll take a look at the Azure portal. We'll find our IoT hub. So as we did before, we can search for IoT Dash. We can find our hub resource. We'll see here on overview, number of messages used. We do in fact have messages sending. We have sent a total of 8 messages, not many, but it's a start. We have 1 connected device and 1 total device, as we would expect. So we're going to click on IoT Edge, and from the IoT Edge panel you will see our device, our total module count, connected client count, and then we can go to IoT Edge deployments. So you'll see here that we have a deploy temp sensor sync deployment name. We targeted dev as we mentioned, and under system metrics here we targeted one and we applied one. So that means that this deployment has in fact already been applied to our Edge device that's running in eFlow. If we click on the deployment, we can review some of the deployment details. We can take a look at metrics, and you'll see targeted devices 1, applied devices 1. So imagine if you have a fleet of devices, say 1,000 devices that you're rolling this out to. IoT Hub will roll this deployment out in a way where it can handle system load. So not all devices were to receive updates at the same time. We can review the modules that were part of it. So you can see here all the modules that we reviewed earlier. We can look at routes. So these are the routes that we looked at earlier. And we can also just look at contents here. So the same manifest that we did in fact just upload. So if I scroll here to the right, we can in fact see our routes. So I'll close this panel, the X. Let's come back and look at our IoT Edge device and take a look. So you'll notice that we have modules in an error state. We do expect these to resolve as it finishes the deployment.